Hello students, welcome to Physics Pathshala. The next class is dimensional analysis. Dimensional analysis. In this, we will be studying two subtopics. What is dimension and how to find out dimension of different physical quantities. Next is application of dimension. This part A and part B. Now, under what is dimension and how to find out dimension of physical quantities. Derivative dimension का बात करेगा. Dimension is another way of measuring physical quantities. This dimension says about characteristics of physical quantities, and there are 7 dimensions to express physical quantities of physical body. These 7 dimensions are 7 fundamental quantities of SI system. Those are mass, length, time, electric current, temperature, amount of substance, and luminous intensity. Out of this, these 3 are of mechanical, this is your electrical, and this is of thermal, and this is optical nature. Now, mostly you will be using this MLT to express dimension of a physical quantity. Now, this dimension is another way of measuring physical quantity, that is replacement of or in place of unit. Like units are used to express measured value of in physical quantity. Here, similar manner, dimension also will represent measured value for physical quantity in terms of 7 dimensions. Now, dimension of any derived quantity says expression of derived quantities in terms of fundamental quantities. Fundamental quantities are M, L, and T. That means physical quantities are mass, length, time, and the dimension is M, is L, is T, and they are expressed in terms of side square bracket, the powers These are the fundamental quantities. Here, once we find dimension of derived quantities, suppose it is our speed or velocity, it is the distance upon time. Distance is represented by length, by time is length dimension is L, t dimension is t, then it become L to the power 1, t to the power minus 1, and we can say L t minus 1. Here m is not available, we can say m to the power 0, m to the power 1, and t to the power minus 1. This is the dimension of speed or velocity. That means dimension is definition of dimension says dimension of any derived quantity is expression of dimension, expression of this derived quantity in terms of fundamental quantities, and these are the powers. Dimension says these are the powers or exponents to which fundamental quantities are raised to express the derived physical quantity. How to find out? Next question is how to find out dimension of derived quantities. Steps number 1, we need to find out is dimension formula. Then equate this dimension formula. This is our dimension formula, that is expressing in terms of m and t, and the m raised to powers of x, y, and z, and expressed in terms of inside a square bracket. Then equating this dimension formula with the physical quantity. Now this dimension of physical quantity is m to the power x, n to the power y, t to the power z. This is our dimensional equation. Now, to get this dimensional formula, first we have to find out, we need to find out physical formula, physical relationship of physical formula for that physical quantity. Suppose our physical quantity is speed. Example, if physical quantity is speed or velocity, we want to find out its dimension. Then first step is to find this physical relationship, that is speed is distance next is to find, next will be to find dimensional formula. That is to convert, dimensional formula is to convert this physical formula into MLT form. That means distance is represented as L, length upon this time, and this speed became L t minus 1. There is L, here t, here it became L and t to the power minus 1 equal 1. Here it is L 1 and t minus 1. M is missing, this quantity is independent of M. In that case, we can write this M to the power 0. So M नहीं हमें सेठी लिख पाएगा M to the power 0, and 3 is we have just equated this dimension, that is speed of dimension speed equal to m0 l1 t minus 1. That means dimension physical quantity बाहर करेगा. 3 steps we have to follow. Number 1, first step is हमें तार physical relationship बाहर करेगा पड़ेगा. जो physical quantity देगी in terms of physical relationship or physical formula. This is your physical formula of that physical quantity. That means like speed is equal to distance upon time. This is our physical formula for that physical quantity. प्रथम एटा बात करा. तापर next step is physical formula को convert करा पड़ो in terms of MLT form. एटा our conclusion है. Correct. Now we got speed is m0 l1 t1. Then we equate to this and get this is your dimensional formula. This is your dimensional formula, and this is our dimensional equation. Okay. This is what required, and it shows dimension of speed is, answer is dimension of speed is zero dimension in n, one dimension in L, and minus one dimension in T. Or once we express this inside the bracket, so this is also answer. With this help, we can find out dimension of different physical quantities. Suppose we have a lot of physical quantities in mechanics. Our length, already you know, length or distance is dependent with our length, and dimension is L. Here, mass is M, time is T, then speed or velocity. Dimension is distance upon time. This is L t minus 1. Area is length, breadth, which is again length times length, becomes L, or it becomes L square M L T minus M0 L2 T0. Here M is 0 L1. Likewise, we have balloon. Dimension is balloon's length, breadth, and height. This length to the power 3 or M L T minus M0 T0. What is gravity? Density, mass upon volume. In that case, it becomes M oblique L3 is equal to M L minus 3 T to the power 0. This is the dimension of density. Next, already speed, acceleration. 1, 2, 3, 4, 5. This is velocity upon time. Is L t minus 1 by t. It is L t minus 2. M is 0. Momentum, mass times velocity. This here M L t minus 1. L t minus 1. Next is force. Mass into acceleration. That case M L t minus 2 and become 1. Work done or work dimension is force into distance. In that case it becomes M L t minus 2 into L, and it becomes M L2 t minus 2. M1 L2 t minus 2. Energy is same as what? It is kinetic energy, it's also energy, potential energy, kinetic energy half mv square, potential energy also same energy or work energy, that is mgh, is same work double work when heat is also energy or work done or work. Now, torque is force into distance or m l t minus 2 into L. also same as work. This is torque or moment of force. Moment of force. Momentum, mass into velocity, mlt minus 1. Next is pressure, force upon area, mlt minus 2 upon L. This became m L minus 1 T minus 2. Stress is force upon area, strain is change in length by length, that is L by L or M0, L0 and T0. This is dimensionless. This is dimensionless quantity. It has this also unitless quantity, unitless. Next, modulus of elasticity. Modulus of elasticity, that is stress upon strain. Strain has no dimension, it is dimension of stress. That is force upon area, L by L is ml T minus 2 by area L square minus 1. This modulus of elasticity or Young's modulus nine. Surface tension 19 is surface tension force upon length. Surface energy is energy upon area. Velocity gradient. Velocity upon distance. Pressure gradient. Pressure upon distance and pressure energy. This is pressure to volume. Next is coefficient of viscosity. is force of one area into velocity gradient. Next is angle, that is theta, is called L by L. It's become M L T0. It's dimensionless. Or trigonometric functions, sin theta, cos theta, tan theta, this theta is L by R, arc, the radius, L by L. Sin, cos, tan also L by L, length upon length. They also have dimensions M0, L0, T0. M0, L0, T0. M0, L0, T0. Correct. Now, the radius of gyroscope, that is again length, moment of inertia, that is mr equal to I, that is mass into f r square, or m into L square, becomes m L2 T0. Next is angular, one is impulse, force into time. Next is angular displacement, that is theta. Angular velocity omega, that is theta upon t. Angular frequency in omega 2 pi f square 2 pi by t. Frequency is equal to mu is equal to 1 by t. This m L is t minus 1 0 0. Angular acceleration is pi square to omega 1 time. Now we have some thermodynamics physical quantities or thermal quantities. Already you have heat, thus write certain thermal quantities. Heat produced heat or enthalpy. Next is heat capacity or entropy. Heat capacity or entropy, that is heat upon temperature, is heat energy, it is water, mLT minus 2, this is 1. Second become L into T minus 2 upon K. K for temperature. Next is specific heat capacity. Specific heat capacity, that is heat oblique mass into temperature. Next is latent heat. This heat oblique mass. Next is thermal coefficient or thermal conductivity. Equal to heat into distance per area on temperature on time. Some constants we have, that is universal gas condition R you can get P is equal to N R T, or R became P divided by N times T. Next is Boltzmann constant K is equal to P by T. Next is mechanical equivalent of heat. J is equal to watt ton by heat. This is mechanical equivalent of heat. Refractive index, that is speed of light in space, speed of light in medium. Medium is the speed of light in space, that means it is velocity upon velocity, or speed upon speed, hence it is dimensionless. Now we have certain electrical quantities. Current dimension is I, dimension is A. Electric charge Q, electric charge Q is, this is current into time, this is A into T, it became A, T, and ML are 0. Next is voltage or potential or electromotive force E. On three cases, we write E is equal to work done upon charge, that is our mLT minus 2 upon Q is our A. AT, yes. Now it became mLT minus 3 A minus 1. This is once voltage dimension is available, we can get dimension of R resistance. R is equal to V by I. Then capacitance of C is equal to Q upon V. Next is inductance. L equal to E upon di by dt or G upon I oblique T or V T oblique I. Our next terms are resistivity. Resistivity is rho A. Resistance is rho L by A. Rho is equal to R A by L. So conductivity is equals to 1 by rho. What is permittivity? Vt epsilon. Here F is equal to 1 by 4 pi epsilon Q1 Q2 by R square, or epsilon is equal to Q square by F times 4 by F times R square, or it became square by F into F square. R is distance, it is expressed in terms of length. The relative permittivity or dielectric constant is epsilon by epsilon 0, and it is dimensionless.